What's up guys, you're on GCSE revision with Daniel Dallas. Today we're gonna go through a circle geometry short problem that's medium level. So grab your pen, grab your notes, this is revision. Let's get started. So we have the problem related to a circle. Just read carefully, pause the video, try to do by your own, and let's get started. So we have the point O as the center, we have the circle, we have two tangent lines, segments in this case, ML and MN, so that L and N are touching points. And we also given the area of the full circle here, 25 pi. So we need to figure out the length of the major arc LN. And let's get straight to the point. We need to find the length of LN, the major, corresponding to a greater angle. So that's why that's actually our arc length around, so from point L to point N. Let's mark the angle here as angle X. So that's why this angle is going to be 360 minus X. Okay, so we know that. So first of all, we need to find angle X and then express the length through that angle. However, we need to write the equation how general we can find the arc length. So the general idea is simply we take into pi r, that's the circumference length, where r is the radius. In this case, radius is OL, and we're taking basically the fraction from that length. We're taking the fraction in terms of the angle corresponding to this major arc. The angle is 360 minus x, so 360 minus x degrees to 360 degrees. That's the fraction. So this fraction 360 minus x over 360 is a part of the full circumference. So that's why we use the angle basis. Okay, so let's do that. And first of all, we need to find radius, and we also need to find angle X. Okay, so what's to start from? I think it's great if we start from the angle, because it's much easier to determine. So first of all, we need to say that OL as a radius is perpendicular to the tangent line that goes through the point L and M. So what it means that this angle is 90 degrees as well as that. So that's we use in the theorem about the radius and the tangent line where they meet in the common point. Okay, so that's why we have 90 degrees. And if you have a look at the quadrilateral MLON, we figure out it's not the cyclic because it's not inscribed in the circle. However, general properties as for any polygon for a side. So the sum of the angles is going to be 360. So we can write that sum of the angles in the quadrilateral LONM is going to be equal to 360. Just here I'm using the formula n minus 2 times 180. But I hope that you remember for any quadrilateral it works. And you need to know the number, okay, as the same as for triangle, 180. All right, so sum of the angles, let's complete. 40x and 2 by 90. So 40 degrees plus angle x plus together 90 will give you 180. That's the sum of all angles in the quadrilateral. The result is going to be 360. And if you transfer that right here to the right side, we'll get that 40 plus angle x will form 180 degrees. Okay, so you can mark as the rule, so you can use that shortcut on your exams when you be solving paper, for example, and that's is ready to use. So one more time, what we figure out that tangent, if we have quadrilateral, two sides of which actually tangent coming from the external point to the circle, we know that the opposite angle as the central angle, and so no matter, actually it might be no, that's exactly, yes, so this should be definitely the angle which is the central one, LON, otherwise it won't be 90 degrees here. Okay, so we use that, and now we can figure out the value for x. So x value is going to be 140 degrees. So that's why we can simply plug in, and we found x. Now it's time for the radius. Let's go back to the radius. How we can do that? How to find the radius? What's the length? We know the area. Okay, so radius can be found from the area. Area of the circle is pi r squared by definition. In our case, that also equal to 25 pi. So that's why from here, if we equate both sides, we know that the radius is 5, taking the square root of 25. So we found the radius as well, and now we just simply plug that into the formula. Finally, we can figure out the LN major arc length. So LN major arc length is going to be equal, so 360 minus x is 140, so 360 minus 140 degrees over 360 and times 2 pi r. In our case, radius is 5, so we can write as 10 pi. Okay, and now what we need to do, we need just to cancel that fraction. 360 minus 140, 220. So we'll get 220 over 360 and times 10 pi. Okay, so if we cancel that, 2 zeros on the top and in the bottom, and you also can cancel 22 and 36 as 11 over 18. 11 over 18, yeah. So, and, okay, I write 11 over 18 and still 10 pi. What we can do, so we can still cancel 10 and 18 by 2, so we'll get 5 and 9 over there. So in total we have 55 pi over 9. So final result for that, just squeeze a little bit, and final result for the LN arc is going to be equal, the length of that is going to be equal 55 over 9 pi. That's the final result, and make sure you have the same. So for those who using a calculator, they might have 55 over 9. They might have the figure like, if you write as decimal, 6.1 recurrent of pi. So that's also eligible result. However, it's better to leave as the fraction, and we are supposed to give the answer in terms of pi. No, we're not given. We just need to give any answer. If you like, we can calculate by plugging the pi value, and finally we'll get, so pi times the final result in decimal is going to be 19.20, 2 decimal places. So in this case, we're not given any units, so that's why that's the final result in some abstract units of length. Okay, so guys, hope you like that. That was pretty short problem. However, here we saw several theorems applied, and about the polygon, about the angles, and also about the tangent lines. Hope you like that. In the next video I'll also show something about quadrilaterals, which are cyclic one, and other problems dedicated to circles. That was Daniel Dallas. Peace out.